Now, another latch. Now, Q changes while latch is opaque, especially if D comes from far away driver. What is happening?
So can we say a noise is coming at the X node? That is why if latch is even opaque, these so Q is changing.
Noise is coming from?
At the X node, like the point that you have written VDD, the X node we
Okay.
were talking about before. Yeah,
But
this
over
point.
here, I have a feedback there.
Okay, so it will again charge it.
Hmm.
So, but noise is noise. No?
So, okay, what you're saying is that uh, the noise that is coming is more than the noise margin.
Yes, sir. Yes, sir.
Hmm?
That's why. Yeah.
Okay, that is always a possibility. For any latch, that is a possibility. So then you would, what would you do then? If
I'll
the noise
try
margin
to.
is less, what do you do?
Yeah. I'll try to size it like to increase the noise margin.
So how do you size? I mean, we discussed this in last class also.
Beta n is equals to beta p.
Sorry?
The PMOS should be equals to the NMOS.
Yeah,
Like,
if we kind of make it a good VDD by 2 centered inverter,
yes,
both
sir.
the inverters, then I would have bigger lobes.
Yes, sir.
I will have more noise margin of this latch.
Yes, sir.
Okay, that is one thing. But then what about this second input? How does this figure in? See, Q charges when latch is opaque, that is okay, noise margin issue. You would want to make the feedback a little stronger. Second input, does it have any significance?
Okay. So again, the diffusion input thing.
Yeah. See, what is happening now is we are saying this is diffusion input. Now the buffer is very far away. And due to some crosstalk, this went to a negative level. That is where X discharged. So the solution again is using buffered inputs.
So transmission gate would be always off, right? Yeah.
We said it is opaque. So the transmission gate is otherwise off.
So then how X is discharging via the transmission gate?
Okay. This is VDD and ground. What if D goes to minus 500 millivolts?
Okay, so maybe one of them will conduct now.
Both of them will end up conducting.
Acha, हाँ. Yes, sir. Fair. Okay.
है ना?
Yes, sir.
Because this D is a floating, it's kind of a floating thing. The driver is very far away. That is what has been written. So again, when you look at the failure mode as a detective, you have to look at all the inputs that are given. So the first answer you gave is not wrong.
Yes, sir.
But it is incomplete. It is not really the problem, is it? So that is one reason. But in this case, that is not the reason.
Yes, sir. After seeing the second point, like I can understand.
So that is, you have to be extremely careful. All the inputs have to be well validated. So yes, D is going to minus 500 because of crosstalk, because of some noise, anything. Any reason could be there.
Sir, if initially D was 0, then when the latch becomes opaque, then sir, will it discharge?
D was 0, latch became opaque, nothing would happen. Latch is opaque, you have this feedback, it will maintain X to the level it wanted to maintain. It is when D, because it's kind of floating, it is when
Yes.
D gets crosstalk, some charge injected because of some reason or another, and
Yes.
goes to a negative value, which can happen because it's a floating node. Floating node can take any value. Any amount of charge can come or go from it. That is when the problem comes.
Okay, sir.
Is this clear? And also,
Sir,
are you
so-
able to see that all the symptoms have to be accounted for in the reason that you will justify? You have to justify that, okay, my answer will lead to symptom 1, symptom 2, symptom 3, symptom 4, all the 4 symptoms my answer would lead to, and this is how I would solve it.
Sir,
Are you able to see this?
sir, why after latch, sir, VDD is written there? Sir?
We're just showing the static state. We said latch is opaque, so in fact उस latch पे
Sir,
भी transmission gate पे भी I would have put clock and clock bar.
तो ये जो सर ये जो सर डिस्चार्जिंग वाला बैक डिस्चार्जिंग हो रही है, ये तो सर मतलब तभी है जब डी हाई है, फिर उसके बाद नहीं तो जीरो वाले में तो ये नहीं होगा ना सर, अगर डी जीरो है तो।
हाँ, मतलब आप अभी आप कह रहे हो कि -500 मिलीवोल्ट चला गया, if D so 0 था, it went to -500.
यस सर,
है ना? दूसरे केस में it could be that it was 1 and it
Yes.
went to let us say 2 volts.
ये हाँ सर, मतलब दोनों केस में, यस
दोनों केस में होगा,
यस, ओके सर,
है ना?
यस
So noise, crosstalk, whatever can cause it. But what is most important thing is you take care that you've considered all the symptoms when you are analyzing your design. Otherwise, your answer is not correct. You are telling a reason. I know that you understand the circuit, but you have not debugged the problem yet. Are you able to see why debug is a more advanced skill than just circuit designing and just understanding the circuit?
Yes, sir. We need to know all the aspects.
Yes.
Sir, could you explain why is it going negative -500 millivolt?
So there's a floating node somewhere. Some
Yes, sir.
crosstalk came. It can take it to whatever level. Is it not?
Oh, it depends on the step.
Yeah. There was some
No,
negative.
it can be
signal.
positive or negative, right? It
Yeah.
doesn't depend
Because
on
let
the-
us say it was stored to 1. A positive crosstalk came. It will take it to 2 volts. Again, the same problem would happen.
Yes, sir.
है ना?
Yeah. Okay.
ठीक है. So